Machine learning is primarily the natural outgrowth of the intersection of two disciplines, computer science and statistics. While computer science focuses primarily on how do we manually program a computer, statistics focused on what conclusions could be drawn from data. So, machine learning deals with the question of how do we teach a computer to perform specific tasks simply by presenting examples of the task to the computer itself. To take an example, how would we distinguish from a spam email from legitimate emails? The input, as you know, is a simple email document which is no more than a collection of characters. And moreover, spam message keeps changing with time. The usual way we solve problems using computers does not work here. The computer needs to be trained using email examples for categorizing emails into spam and non-spam. The main goal is that after providing training to the computer, it is now able to generalize the acquired knowledge to new emails. Learning can be regarded as a hallmark of intelligence. And many would argue that a system that cannot learn is not intelligent. Without learning, everything is new. A system that cannot learn is not efficient because it rewrites itself for the solution and repeatedly makes the same mistake again and again. A question that arises about machine learning could be, why learn? The computer does not need to learn to compute the calculations of a salary in a payroll or solve most of our day-to-day mathematical equations. But certainly we need to learn in situations such as navigating on the surface of Mars, since no human has been there. Speech recognition, since we humans are fantastically we do it, but we can't explain our expertise in doing so. Or to take the example of routing on the computer network, because solutions changes with time. Learning is just not one single type. Learning could come in different types. For example, supervised learning, which includes classification and regression. Unsupervised learning in the form of clustering, association, density estimation, reinforced learning, or semi-supervised learning, active learning, so on and so forth. But I would like to give you another example of how machine learning was applied for commercial business. A US Midwest groceries chain applied machine learning to analyze their local buying patterns from the data of sales that was stored in its database. The learning found out that when men purchased baby diapers on Thursdays and Saturdays, they also tended to go and buy beer from the same store. Furthermore, these shoppers usually did their weekly grocery on Saturdays. During Thursdays, they only purchased a very few items. Armed now with this knowledge, the owner of the chain could make new display arrangements of beer and baby diapers. That is, he went on to put the beer racks beside that of the diapers. He also made sure that both these products were always available on the days of high demand. This led to increased profits and demonstrates clearly the revelation of hidden knowledge. I repeat, hidden knowledge within data which was not known until the use of machine learning. Much of modern machine learning activity can be traced to the second half of the 20th century with Samuel's learner for the game of checkers, where the program played against itself and could achieve better than average performance or capability. And also came the early beginnings of what is well known as the neural networks. Along the years came artificial intelligence, base nets, and several others. But let us keep in mind that although we have progressed much, our ultimate objective of understanding human learning still remains at large. Machine learning research and associated activity gained much momentum since the 1990s because our computers became faster and more capable of storing enormous amounts of data. The CPU processing as well as the data storage capacity has doubled since the 1980s every 2 years. Businesses now moved to e-business today, which are producing huge amounts of data. And the same has pervaded both at the government as well as the non-government sectors alike. The internet and the present World Wide Web has been a major contributor to the huge amount of data today. The Berkeley research team in the research findings which they did in the year 2005 also states that twice the total amount of available or existing data on the planet is getting generated in just under 2 years. So in a way you could see that the enormity of data generation is today has become the new oil for industry, academia. It comes to a little close to 100 terabytes per day. That is the amount of data generated per day. With this enormity of data, we now live in a world that is interesting. Can you predict it to me? So what is it that we are trying to know through machine learning? Questions like, do I have a serious heart disease? How strong will be the wind tomorrow? The common underlying thing in all these situations is nothing more than picking hidden knowledge from the vast data available. Applications of machine learning today has a very wide spectrum. In the form of business intelligence that includes improved supply chain and customer relationship management systems, medical diagnosis of diseases, bioinformatics to classify DNA sequences, speech recognition, handwriting recognition, face recognition, stock market analysis, credit card fraud, search engines, and robot locomotion, to name a few.